In this example, I want to introduce energy in a simple harmonic motion. So basically, what we're gonna see is the introduction of energy to the same problems that we're being used to it. So one equation that relates all of them is this one, which is the elastic energy, which is abbreviate to UA, which has a value of 1/2 K8 to the second power. The kinetic energy, which is 1/2 mass velocity to the second power, V max to the second power. UP, which is the elastic energy but at any given point. The UA is the amplitude. The K0 is equilibrium, and in this case is to any other point. Like it's not gonna be neither the amplitude nor the equilibrium. That's why we're given this value of UP, which is elastic energy of any point, different point, which has a value of 1/2 K XP to the second power. XP to the second power. And this one has a value of 1/2 mass velocity P to the second power. And the addition of these two is gonna give me the total of ME. Alright, so my total mechanical energy. Here is this one is in equilibrium, and here is amplitude. We use elastic energy when we're talking about amplitude. It's kind of confusing, but with example we're gonna be clear. So one equation that relates all of them is this one. UA, which is the amplitude, equals to kinetic energy, which is this one. Here's its value. UP, the elastic energy at a different point, plus the kinetic energy of other point. Here's the value. And when we been asked for the velocity at a position, we're gonna use this formula. So in this example, it asks for the max speed. Here is the key, and the speed when is at negative 0.2 meters. That's position. So we, for sample B, we need to use this formula. And here for the total mechanical energy with the results. Oh, shit. Here it is. Sorry, I'm explaining this. Alright, so here for A, we're being asked for the max speed. Can you see it well there? Yeah, sorry. When we're talking about the speed at a position, we're gonna use this formula. And for the total mechanical energy of the system, we're gonna use, with the given information, any of this, and that's gonna give you the same. If I plug in this, the numbers that they give for K and A, and for A and B max, they're gonna be the same. If you want to try, you can do it so you'll see that you're gonna get the same result, and that's gonna be your total mechanical energy. So let's start by writing the given information. K is 30, amplitude is 0.4, and the mass is 5 kilograms. So for A, we've been asked for B max. So we're gonna write this equation. We're gonna substitute its value for UA, this value, for K, this value, for UP, this value, and for KP, this value. Alright, so we see that we don't have any value for this one, so we cross it. They are gone. So for K we have 30. For A we have its value and the mass, and we're looking for B max. In this particular example, first of all, we're gonna cancel the 1/2 because they are the same. So we left with Ka to the second power, which is amplitude, and M and B max to the second power. So we're going to move the mass to the other side, and then we're gonna square root both sides. What's gonna happen is that Km are going to be inside the square root, and the 2a are gonna eliminate the second power because they will cancel, because when you have a square root and the second power, they cancel, but these two, they don't have it. That's why A is gonna be outside. So for K, B max is square root of Km times amplitude. The value for K is 30 and the mass is 50 and the amplitude is 0.4. So my B max is gonna be 0.8098. Alright, meters per seconds. Meters per second. So the next question is asking for the speed when it's at negative 0.2 meters. In this case, we're gonna use this equation. I can't explain, so I'm gonna leave it 1 second so you can catch up. So we're going to be, for the speed at a given point, we're gonna use this. So here, when it's at negative 0.2, that's my x. So we'll plug in the formula. X is the position, K is 30, M is 5, the amplitude is 0.4, and the X, P is this. We do that, and we got B 0.85. For the last one, like I said at the beginning, we are with the given information, you do the, here it is. Alright, here with the total mechanical energies, you only substitute the values that you already have, and that's gonna give you the value. For example, I plugged in the K value and the amplitude, and it led me to 0.40 joules. And I did the same the second formula or values, and I get the same. So this is gonna be my total mechanical energy of the system. Thank you so much for watching. these examples came from the course prep that is online. I'm just reviewing and sharing my experience with you guys. I hope this helped. Thank you so much.